Hello everyone, a very good morning, good afternoon to all of you. So dear authors and all the invited guests, a very warm welcome to the technical session 9C, and myself Yashita, and I'll be your moderator for this session. So I'll be making sure that everything runs smoothly. So, on behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communication Technology for Intelligent Systems, which is ICTIS 2026. The 11th edition of this conference is being organized in a hybrid mode. The physical event is being held today in the Bangkok, while the virtual sessions are being conducted here via Zoom from 9th to 11th April, while people from all over India as well as from other countries are present with us. I hope you all enjoy today's insightful and knowledgeable and interactive sessions. So, in this session, we will be having total 10 presentations. Each presenter will be given 10 minutes for their presentations, followed by 2 minutes for question and answers. From the session chairs can ask their questions, or anybody from the participants can ask their questions. So I will be giving a gentle reminder at the 9 minute mark to everybody, just to help everyone stay on track. Also, small request to all the participants, please stay connected with us till the closing remarks. We will promise that it will be worth it. So if you have any queries or updates, feel free to drop them in the chat box anytime. Me and my co-host will be addressing those queries. So before we begin, I would like to introduce our esteemed session chair for today. So we have with us Professor Samar Mauket, who is a professor in the Department of Information Systems at the University of Sharjah, UAE. With over 30 years of academic experience, she specializes in management information systems, focusing on user behavior and technology adoption in emerging economies. Her research interests include continuous usage intention, enterprise resource planning (ERP), e-business and e-royalty, and emerging technologies. So, welcome, ma'am. Welcome to the session.
Thank you. Thank you very much for these nice comments.
And the second session chair we have with us is Dr. Nagesh Zadhav, who is a professor and head of BTech CSE Cybersecurity and Forensics in the Department of Computer Science and Engineering at MIT School of Engineering, Pune. So his research interests include artificial intelligence, machine learning, deep learning, affective computing, and federated learning. So he continues to contribute to academia through impactful research, mentorship, and leadership in emerging technology areas. So, welcome, Nagesh, sir.
Yeah, thank you for having me.
So, let's begin with the presentations for today. So, our first presenter is Venkat Satish Kumar Badithala. Are you there in the meeting?
Yes, madam.
Yes, so he'll be presenting his research work titled as A Review on Crystal's Kyber for Post-Quantum Cryptography. So, yes, you can start your presentation. I'll be stopping. Wait,
Okay, madam.
stop my sharing. Yeah, you can start.
Very, very good afternoon to all dignitaries and shared persons of this session. And ma'am, my screen is visible and my voice is audible. Hello? Yeah, please continue. Sure. Thank you, sir. Thank
Screen
you.
is visible.
Okay, thank you. Actually, here we are presenting a review on crystal fiber for post-quantum cryptography. And my name is Venkat Satish Kumar. I am presenting author. My co-authors are there. My from India. I'm delivering this presentation. So this is my overview of the presentation. First, we will see the abstract, and after that, introduction, and why you require the crystal fiber. After that, some literature already collected from previous researchers. And after that, what you identified the research gaps, or you can take it as important findings. And by after that, I am going to conclude that. And we are having one funding also. That's why I'm mentioning the acknowledgement. So this is very brief abstract of our review paper. So here the basically previous classical cryptography systems are using discrete logarithms and factorizations. But due to the Shor's algorithm, whenever the Shor's algorithm 1994 is updated, all those uh, prime prime factorizations and discrete logarithms will be very easily cracked. That's why it is very important for quantum computing to produce the cryptography. So for that purpose, uh, our National Institute of Standard and Technology (NIST) initiated the uh, uh, algorithms for post-quantum cryptography. In that many number of algorithms are evaluated. That is Andrew, Cyber, and Crystal Kyber are the leading candidates. But NIST is first to standardize that Crystal Kyber as a one of the best post-quantum cryptography standardization. So that's why in our researchers nowadays they are going to work on the cryptography on this type of cryptography in their target applications. So that we are having just introduction about that why I am taking that cryptography as a my review paper or my area of interest in the research. So quantum cryptography, before that classical cryptography, I mentioned that RSA and AES and elliptical curve cryptography, all are the classical cryptography. Those are work on the integer factorizations, discrete factorization and prime factorizations. So Shor's algorithm that will be broken that very conveniently the classical cryptography. That's why there is a need for post-quantum cryptography. So here the post-quantum cryptography is very complicated mathematical problems are there. That's why it is very uh, difficult to crack that algorithm or that methods, mathematical models. So those are depends on the learning with error, ring learning with error, and module learning with error. These are the some basic mathematical problems which are working for the post-quantum cryptography. So here the NIST is standardized that out of those three, uh, they are starting the standardization for post-quantum cryptography by a formal global call in 2016 December. So finally, after many number of rounds, the NIST finalized post-quantum cryptography for crystal paper in three different standard names. Those are Federal Information Processing Standard FIPS 203. That is especially designed for or standardized for general encryption. Similarly, for digital signatures, NIST is standardized two more names, that is FIPS 204, FIPS 205. So now the crystal fiber, why the crystal fiber is very important means it is a lattice-based key encapsulation mechanism. So not only the normal vectors, we are going to take lattice vectors. So the lattice polynomials we are going to take. That's why it is very difficult to crack that even the Shor's algorithm, the quantum computers also. That's why it is a standardized machine learning, module lattice key encapsulation method. I already mentioned that it is FIPS 203. So this crystal fiber is completely work on module learning, LW, learning with error. So here the concept of learning with error means you are going to recover a secret key from a set of linear equations. So it is actually introduced by the in 2005, and it is very plays crucial role in the cryptography nowadays. And this crystal fiber is already using in the present nowadays in the transport layer security protocols to provide the security for transmission of our systems, as well as in our Google Chrome, Firefox, and Microsoft simply supports the same module, that is key encapsulation mechanism. Okay, so these are the three different Kyber standard parameters are there. In the crystal Kyber, three different standards are there. Kyber 512 and Kyber 6768, Kyber 1024. This is based on the size of the security providing level 1, level 3, level 5, and the corresponding parameters also differ like that one. So here the corresponding parameters, we are taking that parameters NKQ, that is the order as well as size of the polynomials and matrix sizes. The variable names are like NKQ. So in fiber architecture, I'm simply taking one example, a very familiar example of our cryptography, that is Alice and Bob. So if you want to send the information by the from Bob to Alice, that is Bob is transmitter and Alice is receiver in this example. So here the corresponding fiber architecture is basically three steps are there. One is the key generation, and second one is the encryption, and third one is the decryption. So in the key generation, the first receiver Alice is generating the key generation, which is two keys are there, encapsulation key as well as decapsulation key. Nothing but encapsulation is nothing but that is public key, whereas decapsulation is nothing but private key, because public and private keys are both are required. Encapsulation and encryption is done by the public key, and decryption is done by the private key. So the key generation algorithm generates the two keys. One is private key and one is public. That is encapsulation and decapsulation. So the Alice send first of all the public key to Bob. So by the Bob, by using that public key of Alice, he is sending whatever the message they want to send. The corresponding Bob secret key also adding with the message. It is forming as a ciphertext and it is transmitting to decapsulation. So at the decapsulation, nothing but at decryption, the Alice is going to receive the ciphertext, and by using the private key of Alice, she is going to decode the Alice data, and as well as the corresponding secret key of Alice. So actually both keys will be public and private keys are required. I'm simply taking one example of your key generation in this slide. So very few simplified equation by the values of k and q as well as n values. And I already mentioned that all these mathematical operations are done by the polynomial ring operations. So simply I am taking very simple example of n, k, q values. So it is producing the public key, that is a comma t, in this way the mathematical calculations. And after that the corresponding encryption as well as decryption of our second and third steps of our Kyber is flowchart of encryption. So by using the whatever the public key generated, by using that Bob is sending Alice public key and sending the message, and it is generating the one vector noise vector, I mean random vector or noise E1 and E2. That means basically this crystal Kyber is very important because there is a possibility of transmission of errors in the transmission. That's why those noises will be there. Still, you are going to transmit and you are going to receive the data. That's why. So finally, the encryption is done. It is generating two values, E and V values. Those are the ciphertext pair. At the receiver side, you are receiving that ciphertext pair, that is E comma V, as well as the Alice is now decoding or decryption by using private key of the corresponding Alice. So she computes the message And message why I'm taking the not M, which is because N means there is a some noise is there. So to round off the polynomial coefficients to closer value, that means to remove the noise, we are going to take the third step so that then the message is recovered correctly. And some of the researchers are done their work in the crystal fiber uh, by using some mathematical calculations for key generation, that is uh, secure hash algorithms, and most of the designs are focused on the optimization of its extensive computational components. So I am simply brief summary of that implementation on FPGA is summarized here. So here many number of researchers are there. So they are presented their methods are integrating hashing and sampling stage of SHA3. So the target device is RTX 7 Vivado. Similarly, Chengsong is implemented like employing multi-path delay commutator. He is also taking the target device. So like that, I am going to take some reviews here. So from this literature, we are going to identify some important findings. So the important findings are polynomial multiplication is more computational extensive operation. That is very, very difficult operation. So it is necessary to employ the optimization techniques for that efficient design. For that purpose, optimized design for require of core operator, that is a numeric ternary transform. So that is required for our optimization. Similarly, the hash functions operator as well as secure hash algorithm, keycog shake, that is to reduce the consumption, as well as if technology evolves automatically, the FPGA platforms are going to be very easily having different advantages. So different hardware implementation techniques aiming at optimization in area are latency. So these are the some important findings we identified. So from that, I conclude my presentation. That is, so post-quantum cryptography compulsorily ensures the future security, because nowadays most of the news also we are seeing that quantum computing is going to evolve. So that if quantum computers are came into the picture, whatever the present classical cryptography algorithms will be easily collapsed. That's why post-quantum cryptography ensures the future security. So out of for that purpose, the NIST is standardized fiber is a standardized post-quantum algorithm. But for we require that optimization required for the real deployment. So that is my conclusion. I reviewed that papers, and from that papers, from that researcher works, I conclude this one. And this work is also supported by ISRO SAC Ahmedabad project with grant number RACS GU 2024 4 by 36. So these are the references. Thank you.
So do the session chairs have any questions for him?
Yes, I have a question.
Yes, madam. Please, madam.
Yes, one question. How do you think organization will benefit from your model or framework? What kind of organizations will benefit from your framework, and how can they implement it? I mean, you are doing a framework, but can it be implemented in a way that it will benefit this organization?
Ma'am, actually, I am not starting the implementation. I'm just reviewing the corresponding NIST algorithm, that is crystal fiber, madam. Actually, I am going to start my research by implementing those. The module learning with error concept. Uh, by using that, we are going to provide the security, madam.
Okay, so what kind of organization you are targeting?
Actually, we are doing the IoT applications, madam, for our transmission of data through IoT devices, madam.
Okay, thank you.
Thank you very much, madam. Thank
Yeah,
you.
the one question from my
Ah,
side.
sir.
As you said, you'll be planning to implement for the IoT devices. How do you see the efficiency in terms of the computation? Because you are implementing quantum things. And
Sir.
when it comes to the edge devices, how do you plan to have an efficient way of secure data transmission over the wireless networks?
Sir, actually, I already, sir, just we are doing the review, sir. You have to start that research and do that, I mean, all those implementations, sir.
All right. Thank you.
Thank you, sir. Thank you, sir.
Okay, thank you, Venkata, for presenting. So, up next, we are having Taslima Supti to present her paper titled as a two-stage explainable framework for infant cry classification with RL-based feature fusion. So, Taslima, are you present in the meeting? Let me check once. Okay, she is not there, so let's move forward with the next paper. So next we have Lakshmi Priyanka. So are you present?
Yes, ma'am.
Yes, so she is here to present her paper titled as Atmospheric Noise Aware Preprocessing for Accurate Change Detection in Satellite Imagery. So you can start your presentation. You can share your screen.
Thank you, ma'am. I hope my screen is visible now.
Yes, it is visible. You can start. And you have to wrap it up in 8 to 9 minutes strictly. A humble request to all the participants. Yes, you can start.
Okay, ma'am. Sure. Good afternoon, respected chair members and researchers. I'm Lakshmi Priyanka presenting a paper titled Atmospheric Noise Over Preprocessing for Accurate Change Detection in Satellite Imagery, are co-authored with Nagarjuna Reddy, Vamsi and Rajashekar Reddy. So, and this are abstract. The atmospheric conditions, the cloud, building shadows, haze, and illumination noise were critically affecting the change detection reliability in satellite imagery. So our purpose is to design an automated user interaction enabled system so that we can rely on the change detection without false alarms. So the system we process have two multi-temporal satellite images. So this will follow the atmospheric noise correction detection and correction first before getting into the change detection. So the thin and thick cloud classification by using the dual matrices, and will correct the shadow by using solar shift shadow restoration, and haze by adaptive haze density correction model. So illumination gaps by the entropy matching. So all these pre-processing steps will be done before the images will undergo the change detection model. So by using this pre-processing technique before getting into change detection, we achieved 98% of accuracy. And so introduction, satellite imagery is used for monitoring for the land use cases, urban growth, and also it mainly used in defense system as well to know what actually the ground changes are, also the urban expansion. So these are the key applications where we can use the satellite imagery change detection to know uh, uh, to know the differences between what was there past and what has improved in the present. So In the existing system, the SIMS CNN is unit architecture and thresholding morphology. All these methods are used currently for the change detection models. And here in SIMS CNN, they are comparing the two images. They are just directly comparing the images without treating the atmospheric noise as the real change, so that in the generated change maps, these atmospheric noise were also present, and they were misleading, giving the false alarms though there was no change. All these atmospheric noise was as making the change maps differently, so that it was there, uh, it was giving the false alarm that it was something present, but actually in the ground change it was not there. In the unit architecture also, it was also pixel level change detection model. So it was also failing when the images are coming with atmospheric distortions. When coming to thresholding and morphology, this is the post processing technique. After the change map is generated, these thresholding and morphological techniques will remove the noise if at all present in the change maps. But this is working on an output, but the actual problem is with the input, where the noise, atmospheric noise, is present. So if we just remove the atmospheric noise initially before getting them to the change detection model, we will get good results. So this is the literature survey that we have done on how the dehazing is working, and how the change detection, how the shadow removal, haze removal is working on, and the cloud detection also, with the various papers. And here are the drawbacks that I found after studying after studying some papers. So first one is the high false alarm rates. So as I mentioned you, here I just want to also give you an real world example why I mentioned high false alarm rates. This is because if you consider defense system, so uh, they constantly check for the satellite images at the enemy borders, if at all some other new camp has organized, or whatever the changes has been happening in and around the border surroundings. So if imagine that currently what how it was happening was like, if the shadow of a tall building or the shadow of a tall tree was there, then the change maps were considered that one was the shadow as also the building or a tree, which was wrong. So it was giving the uh, false alarms, but actually if we see at the ground, there was no change. So that's why it was giving the false alarm rates, making that shadows as also real buildings. So no atmospheric intelligence, like we should not make the image to go into remove for all the remove atmospheric noise removal techniques like haze, shadow, everything. We should be intelligent enough so that only what the atmospheric noise was detected, we need to correspondingly remove that. So poor handling of the cloud coverage also, because there may be thin and thick clouds. If there are thick clouds, then we actually don't know what was under the thick clouds to remove them and to show the actual ground change. So that's why if there were thin clouds, we can manage them, and then we can remove them, and we can show the ground change. If at all that was the thick clouds, we'll show a message back to the user that the clouds were very thick at this point, so you can change the image by selecting with some other data. And also the limited explainability. Current test models are also not using were also not human readable enough, so that so we used a LLM, so that yeah, users will understand. So these are our improvements. So by the thick and thin cloud classifications, and how each uh, how each atmospheric noise will be removed. These are the algorithms which we used. So for thin and thick cloud classification, it was by dual matrices and then spectral based atmospheric removal algorithms. And for shadows, it's a solar shift shadow restoration model that we used. For haze, it is adaptive haze density, and illumination differences our between those two images was normalized by illumination level normalization. So final enhancement stage with the HSV saturation also. This is our architecture. So initially in the input layer, user will input two satellite images. Then this will undergo to the intelligent pre-processing pipeline where they will undergo to the noise detection first, atmospheric noise detection first. If the noise were detected, then it will go to the corresponding noise removal. If not, then the clean images will be displayed. After the atmospheric removal also, the cleaned images will be displayed. Now these two cleaned images will undergo change detection model and algorithm, and then we will if there are any changes, we will show them in a human readable text. So these are the techniques that we have used, and these are the references, ma'am, that I have used for my work. Thank you, ma'am. Can I expect any questions now?
If anybody has any questions, they can go ahead with the questions.
Yeah, no questions from my side.
Okay. So, Samar ma'am?
Yes, one quick question.
Yes, ma'am.
You are talking about enhancing satellite imagery. Okay. What kind of framework you have used for testing?
Ma'am, actually, we have used different algorithms at different stages. It was like a pre-processing pipeline. It was not a single framework that we have used. Many of the models were already there. We have made them as a pipeline so that after for detection and for removal also.
Okay, thank you very much.
Okay, thank you, Lakshmi, for presenting. So next we have with us Shweta Barshe. Is she here in the meeting? Let me check once. No, so she is not here, so we can proceed with the next paper. So our next presenter is T. Jhansi. Are you there in the meeting?
Yes, ma'am.
Yes, so she is here to present her research paper titled as Image-Based Food Detection and Calorie Estimation. So you can start your presentation.
Okay, ma'am. Ma'am, I am visible.
Yes, yes, your screen is visible. You have to complete the presentation in 8 to 9 minutes. Yeah,
Okay, ma'am.
yeah, start. You can start.
Good afternoon, the presenter chairpersons. I am T. Jhansi. I am here to present our work on image-based food detection and calorie estimation. This work was done under the guidance of C.H. Venkatanarayana and along with my team. I'll go with these topics: introduction, literature survey, proposed methodology, results and discussion, and conclusion.
Your slides are not moving. Actually, it is still on the first title slide.
I'm changing, ma'am.
No, it is not moving. You can try to reshare
Okay.
the screen. Yeah.
Ma'am, now visible now?
Yes. Now you can. Yes, it is on the introduction slide.
Okay.
Yes.
Yes, in today's fast-paced life system, maintaining a healthy diet requires tracking daily food intake and calorie consumption. However, manual tracking is difficult, time-consuming, and often inaccurate. So our system is capable of detecting the food items, estimating the portion size, calculating the calories, and providing the nutritional insights such as macronutrients. So in our project, we trained our model on a custom dataset consisting of 80 classes of Indian food images to ensure real-world applicability. So the next slide was, ma'am, visible? This is a literature survey. So before building our system, we studied existing work in this area. The first paper was Deep Food by London author, and they used regional proportional network and mass and M faster as CNN model. While it achieved accurate multi-food recognition and comprehensive data insights, its main limitation was depends on high-quality images, which reduces real-world applicability. So the second paper by V. Gayatri, author, and M. Tanuja, authors, utilizes YOLO V8 for real-time food detection and calorie estimation, deployed via Streamlit web app. It was computationally efficient and fast. However, it relied on a static calorie chart, which limits accuracy for varied food preparations. So our system addresses both these gaps. We don't rely on static charts, and we are designed to work with the real world image conditions. So this is our proposed methodology. So the step one was food detection. We used YOLO V8M, a deep learning model trained on our custom dataset of 80 Indian food classes. It detects food items in the image and draws bounding boxes around them in real time. The second step, after bounding box was created, that image is passed to the depth estimation. We integrate MIDAS, a molecular depth estimation model, which computes relative depth from a single food image, allowing us to estimate food volume and portion size without requiring any extra hardware or multiple camera angles. Step 3. Finally, finding the depth estimation, we calculate calories. The estimated volume is then converted into the weights. Using the predefined food density assumptions, calories are calculated on per weight basis to give accurate portion aware results. After calculating the calories, we suggest a nutritional insights by using LLM analysis. Finally, a large language model generates detailed nutritional insights, including the calories, proteins, carbohydrates, and fats present in the food item. This is the system overview of our project. Firstly, we take the dataset and we can segment the dataset. That means reprocessing steps will be do before the dataset. The food item gives to the YOLO V8. After preprocessing steps done, the food item will give to the YOLO V8. YOLO V8 model will train the dataset. After training, in the training, the YOLO V8 identify the item and make the bonding boxes to the item. After that, that item will go to the depth estimation. That depth estimation will give the depth map. That depth map will, from that depth map, we calculate the volume. After that, we find the calories. These are the results. First image showing here, the first looking at the training losses graph. Our YOLO 8M model shows a smooth and consistent decrease in the loss over 50 ECOPS. This confirms that the model learned effectively without overfitting. So the next image shows the depth segmentation output. You can see how our system accurately separates the individual food regions from a real Indian thali image using depth-based masking. And these are the comparison between the previous used models and present used model in our system. So when comparing with the remaining models, our model get the accuracy of 97%, precision 96%, recall 95%, F score 95.5%, loss 0.05, weight 12%, calorie 18. So this is the comparative study of proposed system with the existing methods. This is the final output of our project. We upload an image. After that, we get an output like this. Bounding boxes are on the top of the bounding boxes. Then food item name is labeled. And after left side, here we find out food item and the weight after the calories. Finally, it represents the total calories. And we give the nutrition summary. So finally, the conclusion was, the conclusion was our image-based food detection and calorie estimation system presents an effective and intelligent solution for automated dietary analysis by integrating food detection, portion size estimation, and nutritional profiling into a single pipeline using 80 food classes and YOLO V8M. We achieve 97% accuracy with low loss. The depth estimation enhances the portion calculation, leading to the more precise calorie estimation compared to the traditional methods. The system also provides both accurate and micro insights, making it highly useful for health monitoring. So these are the references we used for our work. Thank you.
Okay, any questions for her?
Yes, can I have a question?
Yes, ma'am.
Yes. You are testing image-based food detection. Okay.
Yes.
Where did you get these images from?
We used custom data set, ma'am. We take the data set from Kaggle. Yes, ma'am. We used that data set.
Okay.
It consists of 80 classes.
Have you tested it on different types of food, or you targeted specific type of food, like only vegetarian type of food, or in general?
In our data set, they mostly included food items are sweets, Indian sweets, and some non-veg curries, and some some rice items.
Okay, thank you very much.
Okay, thank you.
Okay, Nagesh, sir, any
Yeah,
questions?
Jhansi, there is one question from my side. You used RCNN before the YOLO, right?
Yes,
And
sir.
RCNN suffers from the stage issues as well as like computational issues. So how do you mitigate that?
Yes, sir. By using the YOLO V8M, we can solve the issues because in training model, we mentioned epochs, something, how many times we train the model. In that training, every time we get best accuracy and least accuracy. And
And you
every
also
time we
mentioned
try,
about the accuracy as a 97%, right?
yes, sir.
So, and what is the precision and recall value that you have?
96% and something 94%.
Okay, okay, all right. Thank you.
Yes, thank you, sir.
Okay, thank you, Jhansi, for presenting. So our next presenter is Prasanna Kekare. Are you there in the meeting?
Yes, ma'am, I'm there.
Yes, so you can present. So he is here to present his paper titled as MediMitra Voice Enabled Medicine Alert System. So you can start your presentation and stop sharing. Yeah.
Yes, ma'am. Is my screen visible, ma'am?
Yes, it is visible. You can start. You have to wrap it up in 8 minutes, 8 to 9
Yes, ma'am.
minutes. Yes.
Yes, ma'am. Good afternoon, everyone. I'm presenting my work, our work, Medimitra Voice Enabled Medicine Alert System. It is co-authored by my team, Anish and Anush. We are from PUG's College of Engineering and Technology. So our project focuses on solving a very critical yet often overlooked healthcare problem, which is medicine adherence. This is a problem as medicine non-adherence is a serious global health issue. Studies show that most of the people lack to take their medicine on time. This leads to worsening of disease and increased hospitalization rates. This problem becomes even more critical in elderly population as they often forget to take their dosage at time, multiple medicine schedules, and they struggle with complex medication schedules as well. So existing systems like alarm or mobile based are not sufficient because they require manual setup. They are not user friendly for elderly users and they lack intelligence and automation. So our main objectives are to improve medication adherence using automated reminders, to eliminate manual effort by using OCR technology, to design system that is elder friendly and to enable real-time scheduling and monitoring as well. And to build low-cost and scalable solution as well. So these are the so from existing solutions are alarm reminders that are too generic and not personalized, mobile-based app reminders which require manual entry. Then there are smart pill dispensers which are expensive and not scalable. So from this existing solution, we found out the gap that there is a requirement of the system which does not require manual data entry, which is low cost, so that low income households can also use it. Then automation is required in the medication sector as well. So to overcome all these problems, we came up with Medimitra. The key idea of our project is to develop a system with zero manual effort. Then how it works? Firstly, we are going to use OCR technology, which will automatically extract the medicine details like dosage and timing from the prescription. Then it creates a personalized schedule without user input. And then at a particular time, timely reminders will be given to the patient for his medication to take on time. Additionally, the system also use cloud connected system allowing caregivers or doctors to monitor patient adherence remotely. This is the block diagram of the system. So basically, user will upload the prescription image. From that image, the features will be extracted using OCR technology, which will extract the important details like medicine name, dosage time, and at what time you have to take this medicine. So the extracted data will be stored in the database. We are going to use MongoDB for database, which will store the data in scheduled manner. Then we are going to use Raspberry Pi, which we are going to use to establish the connection between our system and the Bluetooth or Google Home or smart speaker. This is the methodology. We are going to use structured pipeline for this project. Firstly, the image processing, where they're enhancing the prescription image by reducing noise and improving contrast. Second, OCR extraction, we are going to use to extract the important information like medicine name, dosage, like I said. Then we are going to use NLP processing, which structures the extracted text into meaningful data and stores it in database. And we are going to use scheduler combined with text to speech to give trigger alerts at right time. Then this technical stack, we are going to use these frameworks for our project, like Python and Node.js for backend. Next.js will be for front-end interface, MongoDB for database storage. Hardware will be a Raspberry Pi and Bluetooth to establish connection between our system and speaker. And voice will be Google to text speech engine. Coming towards the result and impact, our system demonstrates several positive outcomes. Firstly, it significantly improved medication adherence as users receive timely and clear reminders. Second, it reduces the burden on caregivers since the system handles scheduling automatically. Third, it is highly elder friendly as it relies on voice rather than on screen, which is not efficient for elderly people. Then what are the real world applications are there? So we can use our system in home healthcare, which as you can monitor your medicine schedules in home itself. Then we can tie up with old age homes, which requires with multiple patients, which require monitoring. And for long-term disease management like diabetes or blood pressure and hypertension. So in conclusion, Medimitra provides smart, low-cost and scalable solution to problem of medication non-adherence. It offers fully automated prescription processing, zero manual effort, and voice-based interaction for better accessibility. This makes it system suitable for real-world healthcare scenarios, wider population, improving OCR to handle handwritten prescriptions, then hospital integration, such as electronic health records for the hospital to use a system. These are the references we use for making a project. Thank you. I'll be happy to take any questions from the side.
Nagesh, sir, any questions? Samir, ma'am.
Prasanna, how do you plan to implement this or package this? Is it going to be application or any IoT device you are planning to develop?
It will be application and IoT device will be, sir, Raspberry Pi, which will just be there to establish connection between your speaker, which will establish the connection between our system and speaker, and timely reminders will be given to you according to your schedule. So that there will be a Raspberry Pi and Bluetooth speaker, which we have at our home as well. Or we can use Google Home or Alexa as well.
All right, thank you.
Thank you, sir.
Yes, I have a question.
Yes, ma'am.
Okay. How will the patient benefit? Are there any benefits for the patients?
As many elderly elderly people like to take their medicine or they often forget to take their medicine on time. It will be useful for them as we are giving voice reminder instead of just notification alerts or reminders through alarm apps and all. So our system will say out your name, like suppose I'm Prasanna. So our system will tell that Prasanna, you have to take this medicine. It's your time to take this, or it's time to take this medicine. As you have to take it, like.
Okay, thank you very much.
So basically, it will be helpful for them to take their medicine on time, as timely reminders will be given by the system. Thank you, ma'am.
Okay, thank you, Prasanna, for your presentation. So next we have Mami Haja Rakatobe. Sir, are you present in the meeting?
Yes, I'm
Yes.
here.
So he is here to present his work titled as Modeling Organizational Sensitivity in Sports Clubs, a neurosymbolic agent-based analysis of engagement dynamics. So are you ready with the presentation?
Yes.
Yes, so you can start presenting.
Hi, everyone. Thanks for being here. Today, I'll present how we model organizational sensitivity in sport clubs. The goal is to understand how clubs react to change and how this affects engagement. We use agent-based simulation combined with a neurosymbolic approach. I'm Mami Ajar Rakotob with Rémi Collier from the University of Réunion. So why does this matter? Volunteer sports clubs are essential. especially in places like Réunion. But they face key challenges, keeping volunteers engaged and coordinating activity with digital tools. These tools are now critical, yet we still don't fully understand the role of organizational sensitivity. The gap is clear. We know individual commitment matters, but not how it combines with organizational sensitivity. That's what we explore. How sensitivity shapes engagement or leads to burnout. So we combine for complementarity approaches to understand organizational change. First, agent-based modeling to link individual interaction to collective dynamics. Second, structuration theory, structures and practices co-evolve through domination, legitimation, and meaning. And third, neurosymbolic AI, combining performance with explainability. And fourth, constrained language model to extract structured data into our ontology. Together, this gives us a framework that is both theoretically grounded and operational. Our approach combines qualitative research with a neurosymbolic architecture. It relies on three components. First, an empirical layer with data from 25 sports clubs in Réunion. A second, semantic extraction to identify patterns in digital interaction and social structures. And third, ontological formalization to structure the data for simulation. These allow us to move from qualitative insights to a computational model of organizational behavior. Let's look at the first two layers of our architecture. First, empirical data stabilization. We take qualitative data and segment it into meaningful units using content analysis. Each segment is enriched with metadata, actor, tools, and context. A second, semantic extraction. We use NLP and constrained language models to detect patterns. These models don't generate freely, they map data onto our schema. This lets us link interaction to structure like domination, legitimation, and meaning, while keeping everything interpretable and aligned with theory. Now, the third layer, ontological formalization. This is where we turn qualitative insight into computational model. We build an OWL ontology with key concepts, actor, digital tools, interaction, and social structure. At the center is the digital interaction, linking actors, tools, and structures. Each interaction both shapes and it's shaped by domination, legitimation, and meaning. These follow structuration theory. Action and structures co-evolve. The ontology is interoperable and feeds directly into the simulation with empirical data. Now let's look at how we actually set up our experiment. We built a multi-agent simulation in NetLogo, which is highly modular. It has four main parts. The agent layer, these are our virtual club members, each with their own social score and engagement. Then the scenario engine. These components dictate how agents interact with digital tools under what conditions. Next, the commitment update kernel. This is where we adjust agent engagement based on their interactions and the club sensitivity profile. And finally, the outcomes, the metrics export module. This gathers all the data on how the simulation evolves. So this architecture allows us to precisely control variables and observe how different organizational sensitivities play out in an simulated environment. The slide presents our experimental design. We test 9 configurations, 1 baseline, 4 soft scenarios with gradual changes, and 4 hard extreme cases. Engagement is dynamics. Update through a sensitivity-based function. Each scenario is tested free results to identify typing points. Overall, we combine profile scenarios and results to identify key drivers of engagement and test robustness. We model 2 organizational profiles, a resilient club and a fragile one. They face the exact same scenarios and conditions. The only difference is their sensitivity in the commitment update function. A resilient profile has low sensitivity, so it absorbs variation. The fragile one has higher sensitivity, making it more unstable. This lets us isolate the impact of organizational sensitivity on outcomes. So the graph displays average engagement across scenarios for resilient and fragile clubs. The resilient profile stays stable with consistently high engagement. It absorbs variation well. The fragile profile shows a clear decline, especially in harder scenarios. Small changes have strong effects, so the difference comes from internal insensitivity, not the scenarios themselves. Now let's read this through the systematic lens. Input are the scenarios, the process is sensitivity, and the output is engagement. Resilient systems stay stable, and fragile one amplify variation. So performance depends not just on features, but on calibration. High sensitivity can stabilize the system. Tracking engagement variability can act as an early warning signal. For conclusion, the main takeaway: how research shows the internal sensitivity, how organizations respond to interactions, is just an important or structural factors in determining how people engage in digital sport clubs. Resilient systems absorb shocks and stay stable, and fragile systems amplify tensions and become unstable. And we propose an integrated approach: qualitative data, ontology, and simulation. The goal is not prediction, but understanding the mechanisms. The key insight: the engagement coefficients make the difference, even under the same scenarios. So thank you for your attention, and we welcome your question and feedback.
Thank you for your presentation. What you mentioned about the agentic, the modeling, right, in your paper. So, what agent you are implementing? Are they pre-trained models you are using? Are you using existing LLMs for that matter?
Yes, we are using. We are in exploratory phases. So we try to use in LLM OpenAI and use their technology to detect a pattern.
All right, thank you.
Yes, I have a question.
Yes.
Yes. You mentioned that the benefits will be for what kind of, let's say, organizations or institutions?
For the sports club, your question is for the benefits for the sport clubs?
Yeah. What kind of sports clubs? Are there specific sports club that you targeted when you were doing the development of your model?
Okay. For the 25 sport club, this is a popular sport club, not a professional, who has they have very more difficulty to manage your association. So our study is for the 25 popular sport club.
Okay, thank you very much.
Thank you.
Okay, thank you for the presentation. So next up we have Silvio Simani.
Thank
Are
you.
you present in the meeting?
Yes. Good afternoon. Yes, I'm here.
Yes, good afternoon. So he is here to present his work titled as Physics Guided Domain Robust Open Set Diagnosis for an Engine Air Path Benchmark. So Silvio, you can start presenting. Will you stop
Yes.
sharing? Yes, you can go ahead.
Okay. Thank you for your kind introduction. So this paper is focused on an application to a benchmark, which was proposed in a couple of years ago during a conference we organized here in Ferrara, and it represented also a competition proposed by a university in Sweden. So the main point is that it represents a possible solution to a diagnosis challenge. So the challenge is the detection and the isolation of faults affecting an engine with a real benchmark developed in Sweden by the Linköping University. So the main problem is that with real models, normally you need to cope with nonlinearities, parameter drift, and especially the presence of disturbances, which are represented in this case by the weather, for example, the change of the temperature of the outside temperature, outside pressure. So this can lead to, for example, misclassification. Another issue in this framework is that you are not always you don't have many data. When we talk about data, I mean with labeled data. So it means that they are classified as fault-free and or faulty. So we, in contrast to, for example, previous works, we proposed for a diesel engine, which was based on a purely nonlinear model. Of course, the advantage of a physics model is that you maintain the interpretability and also the efficiency of the interpretation. So, but on the other hand, you lose for example, the robustness, and it's quite difficult to cope with unknowns. So our idea is to integrate an hybrid in this hybrid approach, because also on the other hand, we investigated also in some previous works an approach which was based only a data-driven method. But of course, one of the, for example, complaint from the industry is that with a data-driven approach, you lose the interpretability, the physical meaning. So it's why we try to integrate both of these approaches. And so our idea is that we, by extracting some what we call the residuals, residual signals are a tool for understanding if there is any malfunctions in your system. So these residuals are generated from the physical model, from the physical system, because the proposers of this competition were making available also the data, real data from the physical system. So we extract these, let's say, from the signals, we extract the most important symptoms. Symptoms means something that indicates the presence of the fault, and then these signals were processed by an encoder that, due to the one of the requirements of the competition is that this the tool needed to be implemented online. So you can't propose some for example, very high computational required, for example, deep neural networks. So it's impossible. So you need to limit the complexity of your implementation, especially so if you want to implement something that needs to work online. So we had here, we have a 4-cylinder model with standard sensors and actuators, for example, temperature, pressure, airflow, mass flow. We generate these signals, we acquire some signals with a given time sample, and then integrating, for example, which is another aspect of our work, is that we consider not only the relations from, or the signals from the process, but also we exploited, for example, some other features derived, for example, using recursive least squares estimation methods, because, for example, you want to extract changes in the mean value or the standard deviation of in your signals. So recursive least squares with forgetting factor can be considered, for example, some other signals, appropriate signals for full diagnosis. And then everything was processed by the one-dimensional convolutional neural network in order to meet, as already remarked, the strict constraint online computational constraints. The management of the disturbances represented one of the main points. So we integrated also the measurements of, for example, ambient signals, which were used for trying to decouple the dependencies of, for example, the faults on these external disturbances, which represents one of the main problems in online fault diagnosis. Another important problem was that the process, the benchmark was considering 4 faults, but there are in the system there were also unknown faults. So your process needed to also indicate something which was not considered in your, for example, training, in order to manage some uncertain air or unknown conditions. So it means that not all data were labeled. The benchmark details are described in the paper. So you have data from a 30-minute standard driving cycle. You need to, so in principle, you have a knowledge of windows where there are no fault, and then you add the injection of a fault, and then you need to detect and isolate your fault without comparing. This is an important point because you couldn't compare the actual situation with the previous one, which makes it quite challenging. So we had 4 faults affecting, for example, the intercooler, the intake manifold, the exhaust manifold. So the 4 parts of this engine. So the benchmark results show that we were able to detect a fault with a very high confidence accuracy, about more than 94%, with a very low false alarm rate, which was possible due to the way of decoupling the effect of the faults. And then we perform also some quite established ablation study in order to understand, starting from a basic approach and including, for example, the windowing of your signals, the encoder, the conditioning, and then the calibration. And you see that you can slowly improve the results. So this approach was successful. Of course, there are some limitations because, for example, of course, it's true that you need an online implementation, so it's limit also the tools or the algorithm that you can consider. And then also another open problem can be, for example, considered in the framework of adaptive systems, because something that we didn't consider is the adaptation. And also another last point is that we can extend our study to, for example, different faults. Okay, thank you for your attention.
Sylvia, good presentation. No questions from my side.
Thank you. If there are any other comments.
No, thank you very much. No more questions.
Okay, thank you.
Thank you so much, Silvio, for your presentation. So next we have Umair Hossain. Are you present in the meeting?
Yes, ma'am, I am present.
Yes, so Umair is here to present his research work titled as Safe Gas, a smart IoT-based gas leak detection, monitoring and automated shut-off system. So yes, you can start your presentation.
Ma'am, can you see the screen?
Yes, it is visible.
Okay, thank you, ma'am. So, hi everyone, I am Umar Hussain, and today I am going to present our paper title, Safe Gas, a smart IoT-based gas leak detection, monitoring and automated shut-off system. So, at first, let me start with a question. What would happen if a gas leak starts in your home when no one is around? And most common answer is within a few minutes, it can turn into a fire, an explosion, or even cost lives. And that's what exactly we planned to build Safe Gas. So, in short, Safe Gas detects gas leaks early, send real-time alerts to your mobile devices, and automatically shut off the gas supply and continues working even during power outage. In simple words, Safe Gas works like a smart guardian for your home gas supply systems. Now, if we talk about the problem statement, so in real life, gas leaks often go unnoticed because we are not all time present at our home, and then the traditional systems are not reliable. If we talk in about our country in Bangladesh, the most common and currently used safety system is a regulator that basically works on the changes of the pressure of the gas. So, but most commonly, we all know that the most incidents gas related happens for the for little gas leaks, like less amount of gas, and that detectors requires a lot of pressure change. So even they are talking that it is a safety system, but in practical scenarios, we have found that it is not it will not work. And then manual shut off is also risky during the if something happened like fire or gas leakage. So if we sum up in online, overall the existing systems are slow and unsafe. Then if we talk about the objectives, our goal was to create a system that is smart, fast, and reliable. So we focused on IoT-based gas detections, automatic and remote shut-off, mobile app monitoring and control, and backup power support. Now, if we talk about what really motivates us for this project, the project is mainly inspired by real incidents. Recent statistics shows a large number of gas-related accidents causing deaths every year. If we see the statistics in 2023 in Bangladesh, there were 2010 cylinder fires causing 23 injuries and 4 deaths. In 2024, gas leaks led to 539 incidents with 53 injuries and 8 deaths from explosions. So these are just not numbers, they represent real human lives. So we wanted to build a system that can prevent accidents before they can happen, because we all know prevention is better than cure. Now, if we talk about the challenges we faced during developing this project, so the first one was detecting gas leakage accurately without any false alarms. Then ensuring reliable automatic shut-off, keeping the system running during power or internet failure, and designing a simple user-friendly mobile app. Then yeah, if we talk about the literature review, we have studied several existing systems, and most of them have some limitations. Like they can detect the gas leakage, but there was not automatic shut off, and dependency of internet, limited sensors, and no remote control or real time monitoring. And we have also observed that there was some lackings about the practical implementations. Now let's see how our system works. So the process is very simple. Sensors continuously monitor gas, fire, and environment. The ESP32 processes the data. The system decides whether the condition is safe or dangerous. Uh, and if any hazard or dangerous situation is detected, it sends an alert to the mobile app, and it also automatically shuts off the gas supply using a servo motor, and everything is updated in Firebase Cloud for real-time monitoring and control. And in online, it basically works by detecting, deciding, acting, and notifying. And for the software and hardware part, we have used Android Studio for the app development, Firebase database, Arduino IDE for microcontroller programming, and Android emulator to test the app. And in hardware, we have used MQ6 for gas leakage detections, flame sensors for fire detection, DST for temperature detections, and load cell sensors to measure how much remaining gas are present in the cylinder. So these are the hardware components. And in the result analysis part, we are seeing the main dashboard of our system, which is showing the real-time situations of our gas supply systems. Like in the dashboard section, we can see if the system is on or off, our remaining gas levels, our room temperature, and the situations like if any gas leak detected or not, and if there is any flame or not. We can also get a predictions like how much remaining gas we have left. And this is the implementation scenario, like where we have tested the systems in real environment. This is the normal situations, and we get both updates on our offline device and our mobile app. And this is a situation where there is a fire near our system. And this is the scenario where there is gas leakage. This is the profile management section, so where users can update their informations, passwords, and any other informations. So if we to conclude, SafeGas is a smart, reliable, and practical gas safety system that detects gas leakage accurately, works even without internet, automatically shuts off the gas supply, provides real-time monitoring and control, and ready for real-world implementations. These are some references, and thank you everyone for your time and attention. If you have any questions, I would be happy to answer.
Yeah, Umar, I have a question. Like, so have you observed any delay in the notification once your application or the model detects the gas leakage?
Yes, sir. There is a little delay because, but the shut-off system is almost instant, which is offline shut-off system. But there is a delay between the notification because the data is first sent to Firebase, then the app passes the data from the Firebase. So yes, there is a little delay between the notification.
And do you have any mechanism to mitigate in case your shut-off system fails? So have you thought of that as any plan B for it?
That's a very good question, sir. Currently, we have only focused on the core functionalities, but yes, this is a very good point and can be definitely improved in the future work. But currently, we don't have any extra mechanism.
All right. Thank you. Thank you.
Thank you, sir.
Yes, I have a question.
Yes, ma'am.
Okay, how how does your application differs from other application? What's so unique about it so that customers would like to implement it?
So, ma'am, if we start from the beginning, this application lets you pair your devices. Like if you purchase on devices, it is not limited only for you. You can pair and unpair this device using our app, and you can use for other users. Also, there is we have tried to build this app as much user friendly as it can, and we have studied other apps, and there was not that much modern UI. And also, if I have to mention that the remaining gas level notification, it makes the app different from others. Like you can know how much remaining gas you have, and it also gives you a prediction on the average uses of your daily gas uses.
Okay, thank you very much.
Thank you, ma'am.
Thank you, Umer, for your presentation. So our next presenter is Shafa Salsabila Fabrian. So Shafa, are you there in the meeting?
Yes, ma'am.
Yes, are you ready with the presentation?
I'm ready.
Yes, so she is here to present her paper titled as Social Interaction, Entertainment, Pastime and Enjoyment, YouTube Uses and Gratification Among Indonesian Gen Zs. So, yes, you can start your presentation.
Thank you.
Very relevant topic, I must say.
Okay, good afternoon, everyone. Let me introduce myself first. My name is Safa Salsabila Febrian, and I'm from Binus University, Indonesia. Today, I will present you social interaction, entertainment, pastime, and enjoyment, YouTube uses and gratification among Indonesia Gen Z. For abstract, this study examines the determinants of continuous intention in YouTube live streaming consumption among Indonesia Gen Z, focusing on social interaction, entertainment, pastime, and enjoyment, drawing upon uses and gratification theory and computer-mediated communication. This research situates live streaming as an interactive digital environment where audience actively negotiate social and emotional experience. A quantitative explanatory survey was conducted among 108 Gen Z subscribers of Winda Basudara YouTube channel, and the data were analyzed using PLSIM. The findings reveal that social interaction and passing time significantly influence continuous intention, whereas entertainment and enjoyment do not demonstrate significant effects. For introduction, digital platforms have transformed media consumption and participation, with YouTube becoming highly popular among Indonesia Gen Z. Unlike passive audience, Gen Z engage interactively, making live streaming appealing due to real-time communication, stronger engagement, and social presence, especially in gaming content. And Winda Basudara is a major Indonesian YouTuber, exemplifies this through interactive and community-driven live stream. However, research on sustained engagement in this context remains limited. The study examines how social interaction, entertainment, passing time, and enjoyment influence continuous intention using uses and gratification theory and expectation confirmation theory. For uses and gratification theory, uses and gratification theory is a view audience as active user who engage with media to satisfy psychological and social needs. In digital context like YouTube live streaming, this interaction is shaped not only by individual motive but also also by platform features such as live chat, real-time feedback, and algorithm. Gamification arises from both content and participatory interaction, making media use a shared social experience. Therefore, applying UGT in live streaming requires considering both user motivation and technological structure to better explain continuous intention. Next, computer-mediated communication or CMC. Explain how communication processes are shaped by digital technologies. While early perspective emphasized the lack of physical cues in mediated interaction, contemporary interactive platforms demonstrate that digital communication can foster meaningful social exchange. In live streaming, real-time chat and direct response create a hybrid of mass and interpersonal communication, enhancing social presence and immediacy. For Gen Z, these features foster connection and community, making CMC useful for understanding, sustained engagement, and continuous intention. Continuous intention is a user decision to keep using a platform after initial adoption based on expectation confirmation theory or ECT. It is driven by satisfaction and perceived usefulness. And in live streaming, it also involves emotional attachment, habit, and social belonging. Integrating ECT with UGT show that fulfill gratification, strength, satisfaction, and engagement, making continuous intention a cognitive, emotional, and social outcome. And then there are social interaction refers to social media to build and maintain relationship, a key motive in users and gratification theory. In digital context, it appears through discussion, comment, and real-time communication. And in YouTube live streaming, features like live chat and direct response enhance social presence and connection, which can strengthen Gen Z's continuous intention. And there are entertainment is a key motive in users and gratification theory, referring to pleasure, relaxation, and positive experience. And in YouTube live streaming, especially gaming, entertainment comes from spontaneity, humor, and unscripted interaction, making it more engaging than pre-record content. For Gen Z, this is immersive experience, encourage continue participation and viewing. And pastime refers to using media to reduce boredom and fill free time, often lying to habitual use. In YouTube live streaming, long and continuous season make it easy for viewers to watch actively or in the background. For Gen Z, this creates a companion-like experience that encourage repeat use and support continuous intention. And last but not least, there are enjoyment, refers to instinct pleasure and emotional response in media use. In YouTube live streaming, it comes from interaction, creator personality, and share experience, enhance emotional immersion. And for Gen Z, this enjoyment encourage repeat engagement with the same content creator. For research model is based on users and gratification theory, which explain that users actively choose media to fulfill needs that shape their continuous intention. In YouTube live streaming, key gratification includes social interaction, entertainment, pastime, and enjoyment, all expect to influence continuous usage. And there are 4 hypotheses for this research. Social interaction has significant effect on continuous intention. Next, entertainment has significant effect on continuous intention. Third, passing time has a significant effect on continuous intention. And last, enjoyment has significant effect on continuous intention. For sampling, we use quantitative explanatory with variable social interaction, entertainment, passing time, and enjoyment. And for sampling, purposive sampling with Gen Z, active YouTube users, Winda Basudara subscriber, and live streaming viewers. And respondent, we have 108 Indonesia Gen Z user with demographic 63% male and 37 female, with majority age between 19 to 25. And occupation, mostly university students with 50.9%, and analysis method we use PLSM. For measurement scales adapted from prior studies with proven validity and reliability, construct social interaction, entertainment, passing time, and enjoyment, and continuous intention. With two instrument section, demographic and research variable. With scale, we use 4-point Likert, which is 1 strongly disagree and 4 strongly agree. And data collection, we use online questionnaire and analysis statistical software for reliability, validity, and structural relationship. The measurement model, we use evaluated criteria, indicator loading, reliability, convergent, and discriminant validity. For indicator loading, all variable acceptable. For reliability, composite reliability. For variable good internal consistency, and convergent validity for all construct valid. Discriminant validity, we use Fornell-Likert and HTMT. The constructs are distinct. The conclusion, the measurement model is valid and reliable for further analysis. This is the path coefficient and the T values. And then the purpose of structural model to test hypothesis and examine relationship between variables. R-square continuous intention in 0.4896, moderate explanatory power, which is 48.6%, social interaction in significant positive effect, which is H1 supported, passing time in significant positive effect, which is H3 supported, and entertainment not significant, which is H2 rejected, and enjoyment not significant, which is H4 rejected. Key finding, social interaction is the strongest predictor. And for the conclusion, continuous intention is driven more by social and habitual factors than hedonic factor. For conclusion, these studies show that social interaction and passing time significantly influence continuous intention in YouTube live streaming among Indonesia Gen Z, while entertainment and enjoyment do not have significant effect. For discussion, social interaction emerged as the strongest factor, highlighting the importance of real-time communication, engagement, and community in live streaming. Passing time reflects habitual use, where live streaming becomes a routine or companion activity. In contrast, hedonic factors like entertainment and enjoyment are less influential, indicating that sustained engagement is driven more by social and habitual needs than by pleasure alone. Implication, I hope the study extends uses and gratification theory by emphasizing the dominance of social and habitual motivation in interactive digital context. Practically, content creators should focus on enhancing interaction, building community, and maintaining consistent streaming schedule to improve audience retention. I think that's all from me. Thank you for your attention. Is there any question?
Yeah, no question from my side.
Yes, I have a question. Regarding the participants, you mentioned that only students and something that about like 50%, I think, something like that. So what about the other 50%? Who were the participants in your research?
Ma'am, sorry, I cannot hear you clearly. Can you repeat the question, please?
You mentioned that your participants were mainly students. And you mentioned, I think it's about 50% students, 50%. So what about the other 50%? Who are your participants? If you go back to your questionnaire or your survey, you mentioned some demographic value, right?
Yes, yes.
Yeah. So who are your other 50%? Hello, can you hear me?
Based on data, there are 63% of respondents are male and 37 are female. And then
Hello? I think there was an issue.
The participation are not equally distributed, with most of them are also in university students, which represents the core of segment of Gen Z in this study. So when I mention demographic, I am referring to this characteristic to describe our sample more clearly. So not exactly 50-50. Our sample is 63% male and 37 female. So yeah.
It's okay. It's okay. Ayala, thank you very much. Thank you. No problem.
Thank you.
Okay, so next up we have with us Miss Shweta Barshe to present her study named as Comparative Review on Benign and Malignant Stage Classification, Benign and using histopathology images. So Shweta ma'am, are you there in the meeting?
Yes, ma'am. Am I audible?
Yes, you're audible. You can start presenting. So this will be the last presentation for today.
Yeah, yes. The
Yeah.
title, I guess, has like
Yes, yes, that's fine.
So
You can present.
I will share the script.
Yes.
So is it visible?
Yes, it is visible.
Okay. So I'm Shweta Barse and I'm a research scholar. I am pursuing my PhD from MIT University. I'm also a professor alongside. With respect to my research work, I am doing this review papers. I am in my research paper working on histopathology images only for tumor classification for breast cancer. That is what I'm working. So I'm just trying to find out how much. It's the start of my work, and I'm trying to find out what I can use further for it. So this review paper will compare the latest deep learning methods which is used to identify the tissues, whether they fall in benign category or malignant category. Because when they are benign, then doctors will give a line of treatment. But when they are turns out to be malignant, they ask it to operate. And it is very important for someone to know whether it is malignant or not, because a lot of cases get unnecessary, unidentified, and then doctors unwillingly suggest to operate. One of the case was of my sister also, and it later on found out that the tumor was benign state. And doctors are using histopathology images for this. We have studies have seen that the deep learning methods are showing a lot of improvements in these kind of classifications. So the objective is to compare these different available models for this, and also the clinical challenges still existing there. So talking about CNN, the deep learning model, CNN has shown strong performance for these histopathology. So popular architecture, if I say ResNet or DenseNet or MobileNet, all these are few that I have studied throughout the papers that I have gone through. 40 to 50 papers I have gone through. So their performance is very well, but CNN is showing, especially they are used to detect the local image patterns. That is, they are very well detecting the details of the set of patterns, such as the nuclear shape or cell or morphological value of a cell or texture of a cell or the colors of those things. One paper has shown that they are extremely well in performing the binary classification, the same benign and malignant, as compared to the subtype classification, such as the 4 stages or more classified. So they show a limitations. But for these two binary classification, the precision they have shown is 0.98 and the recall value is 0.97. The recall value, that is the number of correct tumor values, tumor cases they have identified. There is weaknesses for this. CNN struggles to capture the long-range interactions and global tissue structures. That is, throughout the whole overall image, it is not able to capture this better the tissue structures which are needed to identify. Only the detailed parts, but they are. So WITS, that is vision transformer, is very good for this. This transformer overcomes the several limitations of CNN. One of them is it is able to effectively capture the global relationship and long-range spatial dependencies. So it outperforms CNN also for complex classification tasks, even if the images are of low quality. So one of the paper Park has shown that WITS are good at 92.8% of accuracy, even though the quality of images were not very good. Whereas on the same data set, they tried CNN, which was 86.0%. Also, if we are using a fine-tuned WITS framework, it has also shown the accuracy of 99%. But some limitations, if I say about WITS, they have shown that is the substantial computational resources are required, and generally there is a need of large amount of pre-training data to achieve the performance. So most of the papers have used the hybrid models. They have fused the combination of CNN and vision transformer. Some have also optimized the outputs by fusing the output of these two, so that they will get the fine-grained local features also, global features also. So some papers have shown this performance, such as Pal. He has used the lung and colon cancer classification data set for this. This is multi-scaling, one of the very good method which can go alongside the deep learning methods. M2 has shown that difference between a single scale and multi-scale deep learning models performance. So when we are using a multi-scaling, that multiple angles we are considering to capture, then they are able to capture tissue patterns more effectively. If we take it into a 3 magnifications level, then the combination comes out to be a better accuracy and more reliable. Different scales, the model captures both fine details and structural patterns also, both the things. So both the values, they are effectively enhancing the performance of models. There are foundation models also, which are large scale and strong in generalization, but they also have then limitations for fine details, such as a recent advancement in computational pathology, that is the foundation model. They are a model which are trained on massive data sets of pathology images. They often use the self-supervised learning strategies, and they are someone who works very well on manual level. So if I talk about SSL also, whenever they have shown a good performance, even when the data was not very well labeled. So they can be used for unlabeled data. And this is one of the model, that is prominent foundation model, UNI, Probe Gigapath, Virtual, are trained on data sets which have a long, big millions of set of WSL images. So these models have proved to be robust feature extractors. One of them is Chief, which also takes textual information and gives a clinical understanding. It shows a very good understanding of clinical context, which is very important. So there remains key challenges which a number of papers have identified. Those are some of them I have highlighted, such as data that I have found is limited, poor generalization across different medical centers. That is data set on one hospital to another, then the performance is different. And lack of interpretability and uncertainty in model predictions. If I talk about data availability, so we very well know now that deep learning model are giving good results for high quality and large scale data sets. The data sheet which is properly labeled and defined and curated. But obtaining such kind of well-defined data is difficult because of the privacy concerns of the patients. They would not like to share all the details as such. Some publicly available data sets such as Camelot can be used, but they suffer from some variability such as staining artifacts or inconsistent image qualities or some kind of label errors. But anyhow, those studies have also given some good data sets, such as TCGNA data set or Star 9 dataset. These also are well curated, diverse, and balanced data sets. Then talking about generalizability and domain shift. Domain shifts occur when a model trained on one dataset performs poorly on dataset of different hospital. So the performance of the models degrades as soon as the domain shift happens because pre-trained by some data is not actually performing on another data because of the staining protocols or scanner artifacts or a lot of other issues also. How the tissue preparations are. So to address domain shifts, models must be able to actually work on multi-center data set. So as the same model can be used on different locations. Talking about interpretability and explainable AI. So deep learning models for the doctors are actually behaving as a black box for them because they are not explaining why they have captured so and so kind of cells and tissues, and they directly give the percent of benign or malignancy. So it has to be a thing that if the doctor has to trust on the results, they has to have interpretability. Explainable AIs, some of them can be used for these things because it provides certain kind of transparency, but being under development, again, there are limitations that their explanations can be misleading. So it could be the case for medical sector also that they have to explain very properly why they have identified certain cells and how the cell to cell the difference has happened, how the neighbor cells have affected. So then only explainable AI will be one of the useful thing for interpretability. Then uncertainty in qualification. This is UQ is used to measure how confident model is on its own results. So techniques such as Monte Carlo is or deep assembles these helps to overcome this because these techniques gives multiple variations of the model. They will show 300 to 500 runs on that data set. It is like asking number of doctors to give their opinions and the average of the majority can be counted. But it is must for a model to give why it is confiding on certain class. Practically also, a model should not take too long to analyze a slide. If the models have long sequences, it could happen. Or they should also have the ability to handle a messy real world data because in many cases, when the models are trained on clean and very well overfiltered data, then the messy real world data for them is a nuisance. So altogether, I would say the high accuracy they have shown in current. The multi-scale learning includes performance of other models. If I combine CNN and before that, if I do multi-scale, it will improve the result moreover. And foundation models definitely can give more generalizability, enable the transfer learning. Yes, still the weaknesses, if I highlight the most, that is the poor generalization in the real world. Data from model working on one data set again is not being generalized to other data set. Secondly, the most important is black box model. Model has to be interpretable. And yes, the high cost computation, as much the models are working on in a sequence of methodology, the cost is increasing. Apart from all these, there are few more research gaps, and one of them, which already discussed, model is not aligned with clinical needs actually. The clinical needs, there are a lot of papers who have differentiated into 4 stages of cancers so that they will be helpful for them. But in real, doctors are not made of it. What they need is what things are altogether on those images and what details the image has. They want everything on the image because for them, few things are challenged. If a tumor is benign and if it is going towards at the start of malignancy, they together look similar to them. Also, the depth spread of the tumor is difficult to identify benefit because of the 2D image. So, it has to be that it should convey the right message to the doctors. It should able to give all the details from the images. That is must. So, models should be which are trained on clean and curated data. Hospital data, they are still noisy and variable. We need a robustness, explainability, and validations. Some paper says without explainability, clinical trust and adoptions are not possible. Also, a proper validation ensures safety and generalizability in real practice. So I would like to conclude by saying that deep learning is a powerful tool, but not absolutely ready for clinical things. But we can have a future with when we have generalizability, explainability, and reliability. Thank you.
Any questions for her?
The one question, as you mentioned about the explainability as a future, but if you look at the current, the research and the things happening in the domain of deep learning, I guess
Yes.
the latest models like Sharp and everything are like kind of falling behind. So how do you propose to improve that explainability in upcoming models?
Which model you are saying?
Sharp, SHAP, Sharp.
Okay, what exactly you want to know about this? Sorry,
Explain the
I didn't
explainable
heard the
AI you were
question
talking about. Yeah, yeah. You were talking about explainable AI as a
Okay,
future.
yeah.
But I think with the LM and everything, this the thing is getting like falling behind explainable AI. So if you want to enhance that, how do you propose to do that? Like in your research, if you're planning to do?
Yeah. So, if I talk about explainable AI, yes, it should be enhanced, updated one. Like it should explain ki if I say if I'm using any kind of model and if it is giving a matrix that one cell is being affected by another cell, if I'm capturing that details and if I'm giving to a doctor, I should get exactly what cell differences has happened and why it has captured those values. So those who the doctors will get ki why we are saying it is valid. For them it will be easy when it done with the medical in medical terms. So that much upgradation is
All right.
Okay, thank you so much, Shweta, for the presentation. Samar ma'am, do you have any questions?
Thank you.
Okay, so this was the last presentation for today. As we have come to the end of this session, I sincerely thank all our authors for their excellent presentations and valuable contributions, all the participants for being an important part of this international conference. I truly hope that this session was insightful, engaging, and inspiring for everybody today. On behalf of the entire team, we thank you for your continued support, not just for this 11th edition, but for all the previous 10 editions of ICTIS. So, we look forward to welcoming you again in the 12th version in 2027 as well. So, all presenters will receive their digital certificates via email within 2 working days, and the publication will be live within 7 to 8 months. So we kindly request your cooperation with the ICTCIS 2026 team. So I would also like to extend my sincere thanks to both our session chairs, Samar ma'am and Nagesh sir, for expertly chairing this session. So this is a small token of appreciation on behalf of the team ICTCS 2026 and Global Knowledge Research Foundation and partners. So thank you all once again for your valuable presence. And before officially wrapping up this session, let's capture this as a memory. So I kindly request everybody to switch on their cameras for a group snapshot of this virtual conference. So 1 second, I'll stop sharing the screen. Yeah. Everybody, please, I request. Yeah. Yeah, okay. Thank you so much once again. Stay safe. Take care, everybody. Thank you.
Thank you, everybody. Thank you very much.
Thank you,
you.
Samar
Thank you.
ma'am.
Thank you. Take care. Thank you.